Imagine if you could see the invisible dance that shapes our world, a dance that's happening all around us all the time. This dance is apparent in nearly all aspects of life, and it goes by the name of Brownian motion. Let's explore this as we go about our day to day. As a result of Robert Brown and Albert Einstein's contributions, Brownian motion has been defined as a random movement of particles suspended in space driven by collisions between gas or liquid molecules. So now before I head to the gym, let's see how Brownian motion plays a role in making my morning tea. So notice how as the leaves disperse and diffuse in water, there is a nearly infinite number of random collisions occurring, which causes this process to take place.
Brownian motion is a classic example of something that's known as a stochastic process. This is a process that evolves throughout time in a way that is inherently random. Mathematically, it can be described using calculus.
So let's break it down. Imagine you have a particle's position given by x of t, where t is time. The change in a particle's position over time can be given by this formula as shown to the right. Now when we look at very small time intervals, this formula becomes this differential equation also shown to the right. Now this equation tells us that the random particle's position moves in a way that is influenced by both steady motion and random fluctuations. So now while I eat my Brownian breakfast, let's talk about how we can visualize Brownian motion with graphs. So as shown here to the right, this graph shows three key properties of Brownian motion. 1. Brownian motion has normal or Gaussian increments. 2. Brownian motion has independent increments. And lastly, Brownian motion has a continuous path, yet it is still non-differentiable. Alright, so before I head to bed, let's look at the different real-world applications of Brownian motion. In finance, it models the movement of stock prices in an erratic manner. In biology, it helps explain how molecules move within cells, and engineers use it to design durable materials.